Hi, this is Sanjay Gangal from EDACafe. I'm here with Gil Abraham, Business Development Director, Vision Business Unit at Ceva. Hello, Gil.
Hi.
Thank you so much for joining us, Gil. Tell us about Ceva.
So Ceva is a very established company. It's out there in the last 30 years. Mm-hmm. During the last 20 years, it's been public, been traded public in NASDAQ under the name Ceva. We are dealing with various of IPs. So it goes from connectivity that include Bluetooth and Wi-Fi, communication, 5G, all the way to very low power sensor hub DSPs and AI processors that we'll discuss today.
Yeah. And you come up with something new called NeuPro-M, or I'm not sure if you call it NeuPro-M or NeuPro-M.
NeuPro-M.
Okay. Yeah. So tell us more about NeuPro-M.
So NeuPro-M is our latest AI processor that we announced just 1 month ago during CES. And this is going to be the leading AI processor that Ceva came with. It's a very, Ceva has a very large customer base. Mm-hmm. And during these years, and we have a lot of experience in low power DSPs and in AI. It's actually the 6th generation of architecture of ours. And through our customers, we are listening to their pain points. We see what is going there with competition. And we actually came with a solution to have an AI processor that is faster, with lower power, and maybe even more important, scalable.
Okay, and a lot of companies are coming out with AI processors lately. Right. A lot of companies. So what is different about NeuPro-M?
So I would say that what makes NeuPro-M so special is they pay attention to details. So we looked at things like performance. At the end of the day, you can look around and you can see 2 clear trends in the market. One trend is they're willing to have more and more processing power, and that's because ML prevails other alternatives. It's going to every field that we know. It can be computer vision that goes from classic computer vision to AI. And it can be in how do you do SLAM, and AI suddenly becomes a major part in it. And of course, the obvious things of autonomous vehicles, of recognition, detection, classification, segmentation, and so on. So the necessity of AI is just growing with time. But at the same time, a lot of the gravity of AI processing is moving to the edge. People don't want to wait for connectivity to the cloud. If it's a car, it has to take decision on the spot in the car itself. So imagine yourself that it's a battery-operated system. It can't consume so much power, but still the market wants more processing power. So that's what we're giving with this platform. More processing power with less energy consumption.
And what are some of the technical challenges faced by engineers and designers in the AI applications? And how does NeuPro-M handle these?
So this is a very wide question. So we have many mechanisms. We are calling it a heterogeneous AI processor. It has various mechanisms in order to reduce power or to reduce bandwidth. You can hear many processors that are, if you're looking spec-wise, they're very, very strong. They look very, very promising, but at the end, they're limited by bandwidth, for example. I'll give you a few examples of our coprocessors within our architecture. So first, the architecture made of a core. A core has few engines, so you can decide how many engines you want to use. And that's what we're calling it. It's running on a compound parallel processor. So each engine can work in parallel within itself, within the different parts within the engine, but the engines themselves can work parallel to each other as well. If you're looking even further than that, we'll be able to work in a multi-core structure, meaning that each core has multi-engines, but we can run and operate a few up until 8 cores in parallel. And that gives a very wide flexibility to our customers in order to deploy their solution. If you're looking at the market, there is a problem how to look ahead, how to be current to the challenges to come. For example, the deployment time can take up until a few years, from an IP into integration with an SoC, and then to integrate it with tier 1, maybe system, and then to the end customer. We would like to keep our solution current, even in 5 years' time. And how do we do that? First of all, we mentioned scalability. You can choose how many engines you want and how many cores you want. And that's going to bring you from 8 tera operations per second all the way to 1,200 operations per second. But it doesn't end there. Flexibility means that you would like to have to support various data types. Flexibility means that maybe look at the trends of today, like transformers and 3D convolution, and to have inherent support in today's processor. But again, it's not even ends here. Because what happens if a new architecture is coming? A new operation is coming that we don't know about it now, but this product is going to sit in the market in 5 years' time. So we made sure that we have on each engine a specific vector processor unit that's going to take care of that. That means that even if a new architecture is going to come in the future that we didn't plan ahead for, we'll still be able to handle it within each engine and not going out from the processor to additional accelerator, do this operation and go back, and by that waste power, of course, reduce performance by much and have plenty of latency and so on.
And what applications do you see a NeuPro-M will be used for?
So NeuPro-M is a very flexible platform, meaning that it can sit from wearables through mobile phones all the way to autonomous vehicle and surveillance. So it can fit itself to the solution that it comes to solve. Some mechanism that I'm suddenly jumping into my mind that can fit different various use cases can be a sparsity. So if you're using sparsity accelerator within the engine, you're going to save power, you're going to boost performance, and these are the exact mechanism that going to make our solution fits various uses.
What are the future developments in artificial intelligence related to the use of NeuPro-M?
So that's a very good question. So that's what I try to answer in my previous answer. The idea would be to fit various use cases even if we didn't think about it right now. Okay, so to prepare ahead. So if it is by supporting various data types to let our customers to decide later on in time if they want to use it, maybe it's going to be mixed precision. They would like to use 8-bit, at the same time use 4-bit in some of the layers. And the inherent support that we are putting right now in trends that we see and we think that they are the next thing to come in the AI field. And I'll mention again the VPU, the vector processor unit that's going to give us the flexibility to support any layer to come, even the ones that we didn't think about.
So tell us about any of the automotive companies that might be planning to use NeuPro-M in their autonomous driving applications.
So Ceva has a long relationship with the automotive supply chain. I'm talking about OEMs, tier ones, and of course SoC makers. Some of them are public information like Renesas that is using our IP. And lately we made actually deals with the NeuPro-M that we just announced, also to have to be deployed in the automotive market.
Great. And what is the best way for our audience to find out more about Ceva and NeuPro-M on the internet?
So of course they can contact us through the website www.ceva-dsp.com, and we're gonna reply.
Okay. And Gil, is it okay if I ask you a few personal questions?
Sure, Sanjay. No problem.
So what do you do for fun outside work, or what is your personal passion?
So personally, I like to be with my family and friends. We're going a lot for camping, mainly in Israel. Mm-hmm. I'm based in Israel, and that would be it. I think just hanging out with the friends and then the family together and to see all the kids playing together.
What are your favorite camping destinations?
Ooh, it varies. It can be a desert, a lot of desert we have usually, but also rivers in the north. In Israel, we have from a very dry desert in the south all the way to snowy mountains in the north. So we have various landscapes to visit.
Can you also tell us something about yourself, Gil, that most people at Ceva who work with you don't know about you?
Ooh. I actually once played the villain in a children's TV show for 2 chapters as a favor to a friend, and for my children to be proud of their father. So, I took the guts and I did like I had 2 minutes on screen time, but
that's
quite
great.
A vicious villain. So,
what was the name of the play?
Galis. It's a series, TV series.
I see. Yes. Pretty nice. Pretty nice. I'd love to see a clip from your TV series.
It's very different from my everyday work. So yeah.
Well, thank you so much, Gil, for taking time to record this interview. Have a great day and stay safe.
Sure. You too.
Okay, there is Sanjay Gangal from EDACafe.